Assalamualaikum warahmatullahi wabarakatuh. I'm Zafirah binti Hadidi, metric number 1181506. Today, we're going to be talking about topologies with our issue topologies for WSN. So what is topology? A topology is the layout of how a network communicates with different devices. There are two approaches to the network topology, which is physical and logical. The physical network topologies refer to the actual connections, for example wires or cable, of how the network is arranged. While the logical network topology is a high-level idea of how the network is set up, including which nodes connect to each other and in which way, as well as how the data transmitted through the network. Logical network topology includes any virtual and cloud resources. Next, why is the network topology important? Above all, it plays an essential role in how well your network functions. Choosing the right topologies for your company's operational model can increase performance while making it easier to locate faults, troubleshoot errors, and more effectively allocate resources across the network to ensure optimal network health. And a streamlined and properly managed network topology can increase energy and data efficiency, which can in turn help to reduce operational and maintenance costs. So the next one is there are 5 types of topology in computer network, which is mesh topology, star topology, bus topology, ring topology, and hybrid topology. And each wire of topology have their own advantages and disadvantages. Okay, next let's move to our issue, which is the topology of wireless sensor network, that is WSN. And what is WSN? Wireless sensor networks can be defined as a self-configured and infrastructure-less wireless network to monitor physical or environmental conditions such as temperature, sound, vibration, pressure, motion, or pollution, and to cooperatively pass the data through the network to a main location or sink where the data can be observed and analyzed. In a simple word, it is a collection of sensing devices that can communicate wirelessly. And WSN has begun to be used in various fields. For example, it has been used in military application, medical application, environmental monitoring, target tracking, industrial application, infrastructure and protection applications. For example, WSN is also be used in healthcare, that used as a monitor for the health parameters of a patient. Next, why we choose this issue? It is because nowadays topology issues have been received more and more attention in wireless sensor network, and WSN has begun to be used in a various field. As you have been used in a various field, there are already a high number of current problems in which this network can be applied. And last but not least, the topology for WSN is quite confusing, so that's why we choose this issue. And next, our objective is to identify the problems of topology in WSN and of course to solve it, and to explain topology is the base for WSNs.
Hi, my name is Norzilati binti Yahya, matrix number 1181512. Next is problems in wireless sensor network. There are two problems. First is geographic routing. Geographic routing is a routing principle that relies on geographic position information. It requires each node that can determine its own location. The nodes only need to know the position of their neighbors and the position of the destination to send the data to the destination. Each forwarder will select the best neighbor to send it to the destination. This process is called greedy routing scheme. But sometimes the data packet reach a node that having no neighbors closer to the destination. This situation is called a local maximum. Okay, next is whole problems. Whole problems is a condition where the nodes are not available or available but cannot participate in the actual routing of the data due to the various possible reasons. Nodes near the sink region will die sooner from outer subregions because these nodes send their own data as well as forward outer subregions data to the sink. Then, after very short time, energy hole comes near to the sink region, so the data cannot be transmitted to sink in outer region nodes, which affects the lifetime of the network. Okay, next is design issues in wireless sensor network. First is fault tolerance. Sensor nodes are vulnerable and frequently deployed in dangerous environment. Hardware problems or physical damage or by exhausting their energy supply can cause the failure nodes. Node failures can be much higher than the one normally considered in wire or infrastructure-based wireless network. The function of protocol deployed in a sensor network is to detect the node failures as soon as possible and to handle a relatively large number of failures while maintaining the overall functionality of the network. This is especially relevant to the routing protocol design, which is to ensure that alternate paths uh, are available for rerouting of the packets. So, the second is scalability. Sensor networks vary in scale from several nodes to potentially several hundred thousand. In addition, the deployment density is also variable. For collecting high resolution data, the node density needs to reach the level where a node has several thousand neighbors in their transmission range. So this level need to be scalable by the protocols that deployed in sensor network and be able to maintain adequate performance. Okay, there is a hardware constraint. Every sensor node needs to have a sensing unit, processing unit, transmission unit, and power supply. To enable location-aware routing, the nodes may have several built-in sensor or additional devices such as a localization system. However, every additional functionality comes with additional costs and increase the power consumption and physical size of node. Okay. Fourth is sensor network topology. Okay, wireless sensor network continue to be networks that constrain resources in terms of energy, computing power, memory, and communication capabilities. Of these constraints, energy consumption is of paramount importance, which is demonstrated by the large number of algorithms, techniques, and protocols that have been developed to save energy and thereby the lifetime of the network. Topology maintenance is one of the important things to reduce energy consumption in wireless sensor network. Okay, next is power consumption. The size of the nodes limits the size of the battery. The hardware and software design needs to carefully consider the issues of efficient energy use. Data compression use additional energy for computation or filtering a byte might reduce the amount of energy used for radio transmission. The energy policy also depends on some applications. It might be acceptable to turn off a subset of nodes in order to conserve energy while other applications require all nodes operating simultaneously. Okay, last is transmission media. The communication between the nodes is normally implemented using radio communication over the popular ISM bands. However, some sensor networks use optical or infrared communication, with the latter having the advantage of being robust and virtually interference-free.
My name is Nukaina binti Yusuf, 1181520. I will explain about the suggestion we make for our topic. We found that wireless sensor network works in different topologies. So we suggest three topologies, which are star network, mesh network, and hybrid star mesh network. The first one, since star network works where a single hub can send or receive message to a number of nodes, the advantage for this type of network for wireless sensor network includes simplicity, the availability of equipment options, and the ability to keep the minimum power consumptions of nodes. Second one, for the mesh network, it allows transmission of data from one node to another within the radio transmission range, and also support multiple connections and paths. This network has benefits on redundancy and scalability, where when a node fails, message can still be forwarded to the desired location, and the network also can be extended by adding more nodes to the system. On top of that, the common topology used is a hybrid star mesh network that provide a stable and flexible communication while retaining the ability to keep the power usage of wireless sensor nodes to a minimum. Since it's combined two network topologies, they are stable for large network requirement and allow them to forward message from one node to another. In conclusion, a sensor network has many basic components such as sensing unit, processing unit, and power unit, and also has additional component such as location finding system. The main aspect of wireless sensor network is to minimize the power, which is related on how the topologies are determined. The optimization can be done by having energy awareness in every aspect of design and operation. For designing a wireless sensor network, we need to consider different factors such as flexibility, energy efficiency, fault tolerance, cost, and rapid deployment. All the application requirements to satisfy several constraints such as scalability, cost, hardware, topology change, environment, and power consumption. The advance of wireless networking and sensor technology open up an interesting opportunity to manage human activities in a smart home environment. Wireless sensor network are dedicated to creating a smart networking method that enables an intelligent network and also capable of managing applications that develop from user requirements. That's all from us.